Yeah, I greet everybody out there. You're welcome to Mr. Ola James TV. And I want to greet every one of us. We are children, we are all children. I'm still a child. So, happy Children's Day. And I wish you the best. Many of these you will witness on earth. You will not die young. Say amen. I'm still a child. Okay, now today we are doing quadrilateral. 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 Now, let's go straight. What is quadrilateral or what are quadrilaterals? Now, quadrilaterals are polygons. See, you can say they are polygons. Polygons, they are plane shape, and they are also two-dimensional shape. So if you want to divine them, you can put these three. Say quadrilateral is a polygon, quadrilateral is a plane shape, or quadrilateral is a two-dimensional shape. You will now say that this one for all that, or let me use small letter T because you are starting with this, that has four sides and four angles. Now, look at it. What we are trying to say here is that quadrilateral, once you want to define a quadrilateral, you can say quadrilateral is a polygon that has four sides and four angles, or quadrilateral is a plane shape that has four sides and four angles, or you can say quadrilateral is a two-dimensional shape that has four sides and four angles. That is it. So you can use any one of these. That is the definition of quadrilateral. I believe that is very clear and it's very simple to define. Let us start picking them one after the other because we have a lot of them. The first one is what? Rectangle. The second one is what? Square. The third one is what? Is let's say rhombus. Then the next one is parallelogram. The next should be trapezium, and the last, kite. Now, all these are examples of quadrilateral. It's a quadrilateral. Rhombus is a quadrilateral. Parallelogram is a quadrilateral. Trapezium is a quadrilateral, and kite a quadrilateral. So all these are quadrilaterals. Now let us start picking them one after the other. Before I pick them one after the other, I want you to know the property that is common to all these 1, 2, 3, 4, 5, 6 of them. There are properties that all of them share together. What is that property? We call it general property of quadrilateral. General properties of quadrilateral. General properties. Number one, it's in their definition. Number one, it has four sides. So all quadrilateral has four sides. Rectangle, it has four sides. Square, it has four sides. Rhombus, it has four sides. Parallelogram, it has four sides. Trapezium, it has four sides. Kite, it has four sides. Number two, it has four angles. Yes. Rectangle, it has four sides. Square, it has four angles. Parallelogram has four angles. Rhombus has four angles, like that. The third one, the sum of their interior angles is 360. So if you are asked to give 5 properties of any of these, now already you have known a standing 3 property. That means if you are asked to give any one of this shape here, just say these 3. It is correct to all of them. All of them have these features. They have 4 sides, they have 4 angles, and the sum of their interior angles is 360 degree. Don't forget that. Don't forget that. They have what now? They have 3 already. All of them have 3 already now that you can actually, keep one side. Even if I stop this lesson here, you have known 3 properties of each and every one of these. Now, rectangle. What is a rectangle? Now, look at this. This is a quadrilateral that has 2 opposite sides equal. Now, when we want to divide them, we use that thing that is special about them to divide them. That thing that is special about it, that makes them different from other quadrilateral. Now, what makes rectangle to be different from other quadrilateral is the fact that it has 2 opposite sides equal. Look at it here. This is example of a quadrilateral. Look at it. This is example of a quadrilateral that is rectangle. Now, what I'm saying is that this angle, this side is equal to this side is equal to this side. So this is opposite side. They are equal to each other. This is opposite side. They are equal to each other. So that means it has 2 opposite sides equal. 1 opposite side equal. 2 opposite side equal. They have 2. If you draw it like this also, it is still the same thing. This side is equal to this side, and this side is equal to this side. Oh, this mark, it shows that this one is 2, this one is 2. That means 2 of them are equal. Then it is not equal to this one that is having 3. It has to meet the one that is having 3 before it can be equal to anyone. And this is the one that is having 3. That means this side and this side are perfectly equal. And that is rectangle. Rectangle has 2 opposite sides equal. Now look at the properties of rectangle that you can add to the first 3 that we have talked about. Number 1, it has 2 opposite sides equal. That is number 1. It has 2 opposite sides equal. With those 3 you have learned before, making what? 4. Then the second one is that each of its angles is a right angle. It's a right angle. And right angle means what? 90 degree. Right angle measures 90 degree. Now, number 3. It has 2 lines of symmetry. Now, these 3 plus the first 3 you have learned, making 6 properties. Now, look at it. It has 2 opposite sides equal. Bam. Each of its angle is a right angle. That is 90 degree. A right angle means 90 degree. So look at it here. That means this angle here is a right angle. This one is a right angle. This one is a right angle. This one is a right angle. If I call this one 90, 90, 90, 90, add it together, you will see that it's exactly 360 degree, which is what we said in that one, that their interior angles will give us 360 degree when they are summed together. So this is all about rectangle. We are done with rectangle. It is very, very simple. Mathematics is always very, very simple. Let's go to the second one. The second one is square. The second one is square. Yes, we are going to square now. Oh, what is square? That thing that is special about square. Then this refers to a quadrilateral that has all its sides equal. It is a quadrilateral that has all its sides equal. It is a polygon that has all its sides equal, but you say 4-sided polygon. It is a 4-sided plane shape that has all its sides equal. All the sides are equal here. Yes, how do you draw it equal? You may not be able to draw it equal, but at least your mark should show that it is equal. Look at that, that is the small one. Look at this big one now. Look at this big one. I tried to draw it equal, but if you measure it, they are not actually equal. If You look at it, say, wow, Mr. Ola James drawing very well. It looks so equal, but it is not equal. How will you now show the person that you are communicating with that this is a square? Now, the mark you put here, I put 1 here, then I must put 1 in all of them, showing that all of them are equal sides. If I put 2 here, I must put 2 in all of them to show that 2, all of them are having 2. That means they are all equal. They are all equal. So this is a square. This is a square. Remember, even if you draw something like this for your teacher and you do like this, like this, like this, like this, with this mark, you have shown that you want to draw square. Your intention is to draw a square, but you are not perfect. So you have done like this. This is a square. You are correct. But without this sign, man, it is you can't judge my instinct. If I just think that this is a rectangle, then it's a rectangle. If you draw this one, if I say it's a rectangle, it's a rectangle. If you don't put this mark there, then you have left me to decide on what I'm going to do concerning what you have drawn, because I will be the judge. I will be the judge. So you just have to make sure that you are on top of your game. Remember the marks to put it there so that the teacher can know that yes, your intention is to draw a square. Now let's go to the properties. You know, you have gotten 3 before. Now this one, the first property is that all its sides are equal. All its sides are equal. Number 2, the same thing like rectangle. Each of its angle is a right angle. And I told you right angle means what? 90 degree. It means 90 degree. The third one, this one, it has what? That is 4 lines of symmetry. It has 4 lines of symmetry. Now look at it. Very simple. All its sides are equal. Each of its angles is a right angle. It has 4 lines of symmetry. Plus that one you have, it is what? 6 now. Now look at it. This is a right angle, this is a right angle, this is a right angle, this is a right angle. That is it. And this is 90, 90, 90, 90. This is giving confirmation to the fact that all the interior angles, or the sum of the interior angle, will give us what? Will give us 360. Let's go to the next one without wasting our time. And the next one we are looking at is the rhombus. Rhombus. Okay, what is rhombus? Now listen to the definition of rhombus. This is a quadrilateral with 4, or let's say with all sides equal and 1 opposite side slant. Okay. This is technical a bit. I said rhombus is a quadrilateral with all sides equal and 1 opposite sides slant. Now look at it. That means we have to draw all the sides equal, but one has to be slant. Well, Mr. Ola James called a rhombus a falling square. A falling square. Look at it. This is a square, right? This is a square. This is a square. Okay. If we want to turn it to a rhombus, we push it a bit here like this, to the extent that this straight line here will become slant this way. And when this one slant, this one too will go slant this way. And look at it. When we remove this one, the original one from there, and we remove the original height from here, then look at it. We have this. And this is now our rhombus. Now, all sides are equal but it has one opposite, side, slant. This is slant. This is a slant height. We call it slant. Now look at it. If you want to draw rhombus, it's not very difficult to draw, but a lot of things mistake rhombus for kite. No, rhombus and kite are not the same thing. This one, this way, look at it in just this manner, and connect this to this, connect this to this, then let your mark shows that this is what? A rhombus. That means all the sides are equal, because rhombus have the same feature with parallelogram, but with this mark it will be able to differentiate it from what? From parallelogram. So that is just rhombus. Very fantastic shape like that. Now let's talk about the properties of rhombus. Apart from the first three we have discussed concerning the general property of quadrilateral. Now number one, it has all its sides equal, just like the square. Number two, this one, each of the angle is no longer 90, because this has changed. The only thing that is there is that this angle here is now equal to this angle. They are opposite angle. And this angle here is now equal to this angle. They are opposite angle. See, I put two curves here. So two curves have to be here to show that they are equal. Then I put one curve here. One curve has to be here to show that they are equal. So therefore, we say two opposite angles equal. It has two opposite angles equal. Yes, it has two opposite angles equal. Now remember that a square has 4 lines of symmetry, but immediately you toss this one, you push it like this, you have changed that line of symmetry. You have changed it. Now it's no longer 4 lines of symmetry. It is now just 2 lines of symmetry. It has 2 lines of symmetry. So apart from the first 3 we have discussed concerning the general properties of quadrilateral, now this one is having these 3 again. That is, it is 6 already. So that comes parallelogram. Yes, parallelogram. So this parallelogram is just like a rectangle. It's just like a what? A rectangle. So when we take this one, we have this is a quadrilateral that has 2 opposite sides equal, with 1 opposite side slant. All right, just like rhombus. Now look at it. This one can be drawn like this. This side is equal to this side, and this side is equal to this side, but now slant. Look at it. So this side is equal to this side, and this one is equal to this one. So this is how rhombus look like. Oh no, rhombus can also look like this. It can look like this one and this way. So any way you want to draw it, it just has to be like this. All right, so this side equals to this side equals to this side. So that is parallelogram. This is parallelogram. Parallelogram can look this way or this way. It is parallelogram. It's like a falling rectangle. Yes, I call it falling rectangle when you push it and it just sweeps to this side like this. So it's a falling rectangle. That is it. That is parallelogram. So apart from the 3 properties we've known before, let's take like 2 to 3 more. So parallelogram, just like a rectangle, it has 2 opposite sides equal. It has 2 opposite sides equal. That is first one. The second one is that the opposite angle is now equal. This angle is equals to this angle. This angle is equal to this angle because you have tossed it just like that one. So it has two opposite angles equal. It has two opposite angles equal. And the third one, remember, is a rectangle has two lines of symmetry. If this is a rectangle, the line of symmetry in rectangle is the one that cuts this one into two equal halves, and the second one that comes like this. But now you have destroyed it, so it has no line of symmetry. It has no line of symmetry. It has no line of symmetry. I don't want to go into this side is parallel to this side. That's why they call parallelogram. This is parallel to this side. This is parallel to this side too. So, but don't worry, don't let us go into that. You are too young for that now. So that is it. All right, or we will discuss that in another class. So this is all about parallelogram. Let's go to trapezium. Trapezium. There we will talk briefly about parallelism. Now listen, there is no difference between trapezium and trapezoid. There is no difference. They are both the same thing. They are both the same thing. Now, trapezium. Trapezium is a quadrilateral with one opposite side parallel. Wow. So what do we mean by parallel? Parallel are lines that can never meet. Just like when I take these two markers, this one. All right, when we say parallel lines, that means two lines that can never meet. Look at this. We keep going this way. Can you see it? Yes, they can never meet. So we can say these lines are parallel. You can see they keep moving like this till the kingdom come, and they will not meet each other at any point. They will not meet. So parallel lines are lines that can never meet. Parallel lines are lines that can never meet. Say trapezium is a quadrilateral with one opposite sides parallel. So the best way to draw a parallel line is to draw a trapezium is to draw one parallel line, and they must not be equal. They must not be equal. One must be bigger than the other. All right. So then we can now join them together this way and this way. So this side is parallel to this side. We use this sign to denote parallel lines. This is parallel to each other. Now we can draw it like this too, like this, like this. Okay, let's have it this way. Now look at it now. We join this side together, but we must be able to tell that this side is parallel to this side. So if I put one arrow here, I have to put one arrow here to show that they are actually parallel to each other. If I put two here, I have to put here. If I put one here and I put two here, that means they are not parallel. If I put one here and I put two arrows here, that means they are not parallel. Putting one here and one here shows that they are parallel. Two here means that they are parallel. Now, some people have argued that parallel trapezium now is triangle, right angle triangle to be specific, plus rectangle is a trapezium, or right angle plus rectangle plus triangle. That is a trapezium. If you join this one together now, it's going to give you something like this: a triangle like this and a rectangle this way. Look at it. This is a trapezium. This is a trapezium, knowing fully well that this one is parallel to this one. If you join these three together, it will give you something like this. Look at it. This is a triangle that I've not completed. Then I can shift it this way to this side. Then I can draw another triangle here like this. So this is also a trapezium. This side is parallel to this side. You see, I said that the two parallel lines must not be equal. If you draw it equal, that means you are going to get a rectangle. You are going to get a rectangle. So you can see now, this is a trapezium, this is a trapezium, this is a trapezium, this is a trapezium. So what are we going to say concerning the property of a trapezium? Properties of a trapezium. Apart from the three we have said, that it has 4 sides, it has 4 angles, and the sum of its interior angle is 360. Then the next one we can say is that it has one opposite sides parallel. I want us to just say it only this one. Somebody will say, why, Mr. Ola, why? Now listen, why I don't want to talk about the line of symmetry in this case is that, you see, we have types of trapezium. Let me quickly talk about that. We have type of trapezium. We have scaling trapezium. So I said scaling. We have isosceles trapezium, where the first one here, or let me just draw equilateral triangle first. Equilateral triangle. This one now, all the sides are equal, right? This side and this side are equal. So if I truncate it like this, now I have removed this one and I join this one together, then it becomes a trapezium. But let us look at where it's coming from. It's coming from this place, for the fact that it is a equilateral triangle. This side is a line of symmetry. So if you eventually remove this one on top like this, then it still means that this one has a line of symmetry. This one has a line of symmetry. So they call this one isosceles trapezium. Isosceles trapezium. Isosceles trapezium. Why? Because this side is equal to this side, and this side is parallel to this side. So in an isosceles triangle, two sides must be equal. So two sides are equal. So that is, we got this one from isosceles triangle. So it's going to be isosceles trapezium. Isosceles trapezium. Even if it was, I was saying equilateral, but immediately we truncate this one, we cut it short. That is, they are no longer equal to the baseline again. So it just here equal to this. So it becomes isosceles. So it's isosceles trapezium. In isosceles trapezium, we have one line of symmetry. We have one line of symmetry. Here, there is no side that is equal. I call it scaling trapezium. I call this one scaling trapezium. Scaling trapezium. And that means there is no size. There is no line of symmetry for this one. There is no line of symmetry for this one. So you can see now that if I want to say it has one line of symmetry, what if I are talking about this one? What if we are talking about this one? So that is why I don't want to put one line of symmetry, but you can use your instinct to know that if it's isosceles trapezium we are talking about, it has one line of symmetry. Otherwise, trapezium has no line of symmetry. Is that clear now? Kite. So what is a kite? This is a quadrilateral that has two adjacent sides equal. Two adjacent sides equal. Two adjacent sides equal. Let's look at how it looks like. This is it. One side, this side, they are adjacent sides to each other. They form an angle like this. They are adjacent sides. They join each other to form a particular angle. So this is adjacent to this one, and this one is adjacent to this one. Then they are equal. Look at it. This one is equal to this one. I must be able to show it. But the other one must be longer than this. So if I want to tell my student to draw it, I'll tell them to just trace this one down like this, longer than the one you have done. Put a dot there, then draw a line here with your ruler and get it down to this dot. Draw this one too, get it down to that dot. Then that means they are equal. So this becomes a kite. Okay, let's make it 3. This becomes a kite. You can see these adjacent sides are equal and these adjacent sides are equal. These adjacent sides are equal. These adjacent sides are equal. We can draw it like this too. Some even use it. They use the system of a kite to draw their fish like this. Then this one long and this one too long, like this. You can see. So this side is equal to this side, while this side is equal to this side. Is that understood? To draw kite is very, very simple. To draw kite is very, very simple. I met a student very smart like that. He told me that Mr. Ola James, if I want to draw a kite, I will use my pencil to draw a straight cross like this, a cross this way. Look at it. That means the line, this side is long, but this one is not placed in the middle. It's just exactly a cross. So he will take his pencil and connect this one and this one together, connect this one and this one together, then take it down to this place, take it down to this place, and he will just clean, he will erase this line, the initial line or cross that he has drawn, and this is the perfect kite. So that is it. You can choose anyone you want to use to draw your kite. Just make sure you are drawing a perfect kite and you are putting the mark that will show that it is a kite in it. And now let us talk about the quality of a kite. But before I go into that, these opposite angles are equal. Can you see it? These opposite angles are equal. So property of a kite. Properties of a kite. Number 1, it has, from its definition, 2 adjacent sides equal. It has 2 adjacent sides equal. Number 2, it has 1 opposite angles equal. It has 1 opposite angle equal. Number 3, if I should cut this like this, I have cut it into perfect half. You can see whatsoever it is you are seeing here, you are seeing the same thing here. So it has 1 line of symmetry. It has 1 line of symmetry. And that is all about quadrilateral. Isn't that wonderful? It's very, very simple. It's very, very simple. We have discussed 6 different kind of quadrilateral now. We talk about the square, the rectangle, the rhombus, the parallelogram, the trapezium, and the kite. Please study very well. A workman that needed not to be ashamed, rightly dividing the word of truth. You need to study. Just go ahead, listen to the video again and again and again. Then the sky is your starting point. Thank you very much. Keep loving Mr. Ola James because I love you all. Happy Children's Day. Bye. Oh my, it's taking me